Hi everyone, my name is Thor ZHONG, matrix number 278016. Today, I would like to talk about how I solved the question 1 in this individual assignment. The function given from the question is fx equals x power 5 minus 5x cubed. First, the question asks to find the x-intercept and y-intercept of the function. To find the x-intercept, fx is equals 0 and substitute into the function above. Then can find that the x-intercept is square root 5, 0 and negative square root 5. Same for y-intercept. We let x equals 0 and y-intercept found that is 0. Next, question asks to find the open interval where the function is decreasing or increasing. I differentiate the fx and get f prime x is equals 5x squared bracket x squared minus 3. I form a table with x and f prime x. And finally found that the function is increasing in the range when x smaller than negative square root 3 or x bigger than square root 3 since f prime x bigger than 0. The function is decreasing since f prime x smaller than 0 is in the range between negative square root 3 and square root 3. The question is then asked for the x-coordinate of the inflection point. I differentiate the f prime x and get the f double prime x. For inflection point, the f double prime x will be 0. After calculation, I found that there is 3 x-coordinate of the inflection point which are 0, square root 3 over 2 and negative square root 3 over 2. Then, the question asks to determine the open interval where the function is concave upwards and downwards. To determine the open interval where concave upwards and downwards, we need to know that f double prime x bigger than 0 is concave upwards while f double prime x smaller than 0 is concave downwards. I form a table with x and f double prime x. By substituting different number from various intervals as x, we found that the graph concave downwards on x smaller than negative 3 square root 3 over 2 and also between the interval 0 and square root 3 over 2. The graph concave upwards on the interval between negative square root 3 over 2 and 0 and also while x bigger than square root 3 over 2. Lastly, I continue to find the local minima and maxima of the graph. On a stationary point, the f prime x is equals 0. So, after the calculation, I found that there are 3 stationary points at 0, negative square root 3 and also the square root 3. From the finding above, I know that the stationary point on the 0 is inflection point, so I ignore the coordinate. By using the second derivative test, I substitute the negative square root 3 and square root 3 into the f double prime x. The value calculated smaller than 0 is the maxima while bigger than 0 is minima. Then, to find the coordinate of the point, I substitute the x to the fx and found the corresponding fx. The local maxima and minima point were found. This is the graph I formed by using the information gathered from the calculation above. The important points are plotted such as the x-intercept, y-intercept, and the local maximum point and local minimum point. This is all from me. Thank you.